So we're looking at the second year Stats and Mechanics textbook, and we're on exercise 8D, differentiating vectors, and we're on to question 6. Okay, so given the position vector as a function, it's a function of t, and then I'm given some information about the speed, and I'm asked to find the two possible values of k, and it's an exam question, so I can see it's worth 6 marks. So I know there's going to be a bit to do here. Okay, so if they ever ask for speed or velocity, and you're given displacement, and it's variable displacement, that's going to involve differentiating. So if I differentiate the position vector, I'm going to get velocity. Okay, so quite straightforward differentiating. So the I coefficient is just going to differentiate to 6t minus 6. And the j coefficient is going to differentiate to 3t squared plus 2kt. Just about squeeze that on there. Okay, and obviously I've got this unknown k, to make that look a little bit more like a k. Okay, well, I don't know if that helped. Right, I've got this unknown k, and that's what I'm trying to find. So they tell me that when t is 3, the speed is 12 root 5. So let's get the velocity when t is 3. So when t is 3, that's going to be 18 minus 6, so 12i, and that is going to be 27 plus, so the 3t squared would be 27. The 2kt, well, if t is 3, that can become 6k. Okay, so normally at that point I'd have just two coefficients, so I wouldn't have this k to worry about, and if I needed the speed, which is what they're mentioning here, I would do the magnitude of velocity. Okay, so this is a problem solving question, so it is one where they've mixed things up a little bit. So if I were trying to calculate the speed, it would be the magnitude of the velocity, so square root of 12 squared, and then don't have just a single value for the j coefficient, but I do have this function in terms of in terms of k, and they're telling me that that equals 12 root 5. Okay, so that they gave me in the question. So now I've got that written down, I think I can see where to go from here. Okay, so I just need to, I'm going to end up with a quadratic in k to solve. So always the first thing I would do for a question like this is square both sides. So I'm going to simplify. So I'm going to do the 12 squared, and let's not square out those brackets, but let's write it. So 27 plus 6k all squared is 27 plus 6k times 27 plus 6k, and then I'm going to not do that. I'm going to square the 12 root 5 and get 720. Okay, so then it suddenly looks a heck of a lot nicer. I haven't got the square roots to worry about. So what I've done there is I've squared both sides. Okay, so let's multiply out those brackets. So I've got 27 times 27. I've got 6k times 27, and then another 6k times 27, and then I've got 6k times 6k. So as we said, we're going to end up with a quadratic in k. So my squared term is 36k squared, then I've got 324k, then I've got 729 plus 144 minus 720. So plus 153 equals 0, and then I'm going to be super lazy and just do that straight into my calculator. Okay, so A is 36, B is 324, C is 153, and I'm getting, I'm getting two negative values of k, but I think that's fine. So I'm getting k is minus a half. I mean, looking at that quadratic, look if you could see. Looking at that quadratic, it was going to give me two negative values of k because everything's positive. So I'm getting k is minus a half and k is minus 17 over 2. And yeah, there's no reason why k couldn't be negative. Let's just double check before we move on. Minus a half, minus 17 over 2 or minus 8.5. Okay. And And then for each of these values, so it's just a bit of a pain because we're going to have to do 2 calculations, find the magnitude of the acceleration when p, find the magnitude of the acceleration of p when t is 1.5. Okay. All right, well, so first thing I'm going to do is get the acceleration. So acceleration is going to be the differential of the velocity. So I'm looking back up here and I need to differentiate that. So 6t minus 6 is just going to differentiate to 6. And 3t squared is going to differentiate to 6t, and 2kt is going to differentiate to 2k, and I've got 2 different values of k. Okay, so as I said, it's just a bit of a faff that we've got to do it twice, but in mind, right? So when k is a half, the acceleration is 6i plus, right, t is 1.5. Okay, so 6 times 1.5 is going to be 9, and if k is a half, 2k is going to, sorry, k is minus a half, 2k is going to be minus 1, so 6i plus 8j, and then always read super carefully. They want the magnitude of that, so that's going to be the square root of 36 plus 64, so square root of 100, so 10. Okay, so there's one answer, and that's when k is minus a half. Okay, and then when k is minus 17 over 2, so I can just go back, I've already differentiated, so the acceleration is 6i, a little bit, so 6i, and then I'm looking here, so again that's going to be 6 times 1.5 plus 2 times minus 17 over 2, so it's minus 17, so a is 6i minus 8j, so basically the same, right? So I'm wondering if I did miss something in the question where I could have concluded that before, but never mind. So that, because I don't care about the minus if I'm squaring, so we will just double check those answers. But I am actually getting the same acceleration, the same magnitude of acceleration, so it is 10 for both.